Okay, so we've spent a lot of time writing chemical formulas. And I told you that this is an absolute must. This is one of the foundations of chemistry. You have to be able to write balanced chemical equations, and even before that, you have to be able to write proper formula. So if you think about it, and okay, there we go. So the foundation of everything that we're going to do today kind of relies on accurate formula. Now, for the most part, you're going to be given the formula today. So not a big deal. We're going to assume that you have the formula in front of you, which you do on the worksheets, and you're just going to be doing the math from there. So I just want to get my head in the picture here. Okay, it's a little bit, at least my head's not getting cut off. Okay, so let's start with a chemical formula, and let's build one. So with your periodic table, and if you have your orange, yellowish orange common ion chart, I want you to give me, Dominic, pick one of the 6 multivalent metals. So that's chromium, copper, lead, tin, iron, or mercury. Which one do you want? Lead? And do you want 2 or 4? Okay, so we've got lead 4+. Bella, you're looking at the polyatomic chart, so the top half of the table. Yep, so I want you to find a negative polyatomic. Just find the one that just speaks to you and tell me what it is.
Nitrate.
Good. So what's the formula for nitrate?
NO3 -1.
Okay. So those are our 2 ions. So you remember when we built formula, we cross those over, and if we need more than one of these, we need to put it in parentheses. So we end up with lead 4 nitrate, and that's our formula, okay? As I said, you're going to be given the formula today. For the most part, I think the last worksheet, you're going to have to do a little bit of work and come up with some formula. But let's say this is our formula. You remember what we talked about with balancing chemical equations. We said that the law of conservation of matter states that the atoms have to be the same number on both sides. Not only do you have to have the same atoms on both sides, but you need the same number of atoms so that we have those scales balanced, okay? You cannot create matter and you can't destroy it. So you can't all of a sudden just, lose that lead atom. It has to be on the other side. It's going to be rearranged in some new product, but that's okay. So one of the things we haven't really focused on is, well, let's kind of break this down and count the number of atoms. Actually, we did do this with balancing. So in this, I know that I've got lead. I know that I've got nitrogen. Oops. And I know that I've got oxygen. So tell me how many lead atoms I have in this formula. Amelia, what do you think? How many PV do you see here? It's just 1, right? Because there's no subscript here, okay? So we've got 1. And how many nitrogens do we have? Trinity, what do you think? Yeah, that's good. And what I was going to say is, look at what's inside the brackets first. So you see 1 nitrogen there. So I always write the 1 because it's inside. But now we've got a multiplier here. And you'll remember that this 4 multiplies that, and it multiplies that. It does not multiply the lead. So we got 1 times 4 is 4 nitrogens. And then the oxygens, what do you think, Ariel? How many oxygens do we have? I got 3 inside the brackets, and then what does the 4 do? Good. Okay, so I got 1 atom of lead, I've got 4 atoms of nitrogen, and I got 12 atoms of oxygen for a total of 17 atoms in that 1 formula. That's it, that's counting atoms, okay? Let's try one more. Let me see if I can throw one that's a little goofy at you. Oh, I think what's the charge on the dichromate, Bella? Can you tell me, please? The CR207. What's the charge on it? Is it a 2?
CR207 -2.
Good. Okay. I just wanted to make sure I had that right. So that 2 comes from the CR. The NH4 is a positive 1 ion. So that's the correct formula. So now we got 1, 2, 3, 4 atoms. We got nitrogen, we got hydrogen, we got chromium, and we got oxygen. Again, I've got 1 inside the brackets, nitrogen, times 2. So 2 atoms of nitrogen. Hydrogen, I got 4 inside the brackets, I got 2 outside. So that is 8. Chromium is just 2, and then oxygen, just 7. So what do you think? I mean, that's it. That's counting atoms. That's the first worksheet. Okay? Now there's one other thing that you might see. And again, we go back to balancing chemical equations. Well, what happens, let's say that each of these shows up in a balanced chemical equation, and there's a subscript. Let's say we needed 3 of these, and let's say that we had a 4 in front of here. We could even be reacting these 2 compounds together. These could be our 2 reactants. We could have a plus sign here. What does that do to all of my numbers? Well, all you have to remember is that any coefficient in front of a formula is it's a grand multiplier. So it multiplies everything. Say that again, sorry?
Multiply by like the total number of atoms?
Yeah, so like each individual one, right? So I would just add on a times 3. Each of these, we would have 3, 12, and 36. Okay? Because remember, when you're balancing, you might have to do that because that's what the coefficient does. It changes or multiplies the number of atoms. The 4, of course, is going to change everything here as well. So times 4 is 8. Times 4 is 32. Times 4 is 8. And times 4 is 28. So you could end up with some pretty decent sized numbers. But again, as long as you understand subscripts outside brackets only multiply what's in the brackets, coefficients in front of the formula multiplies everything. Those are really the only 2 rules. So if we take a look at, well, I'll show you the worksheet. I'm going to stop the video here. Actually, I'm just going to pause it.